All right, so first I want to talk about what the video talked about, which was those charges. Remember I said moving forward, you're going to have to know those. Um, and then we'll talk about one of the trends today we're going to talk about is called electronegativity. So one trend we already learned, it was atomic radius. And I know we need some more practice on that, but we're going to do a lot of that on Wednesday. All right, so let's start with something simple. All right. So in the video, it was a lot of information. A lot of it was review. So the only really new thing that I wanted you guys to get were those charges. Okay. And those are super, super important. But let's start with something like aluminum. Okay. So here's aluminum. All right. You should have already known how to determine the number of valence electrons. Can somebody tell me how many valence electrons aluminum has? I'll pick somebody.
3.
Okay, yes, Whitney says 3. And then Whitney, how'd you know that? You are correct though.
Because 13 equals 3, 14 equals 4, 15, and so on.
Exactly, exactly. So this is group 13. You can just say subtract 10, or you can just take the ones off of these. And this will tell you how many valence electrons you have. All right. So in the video, he was talking about fill in or fall back. Let's talk about first, who does everyone want to look like? Who's the it family?
Noble gases.
Excellent. The noble gases. Everybody wants to look like the noble gases because their valence shell, which means their last ring, is completely full. And if there's completely full, how many valence electrons does it have? 8.
8.
Very nice. 8 is great. So everybody wants to have 8 valence electrons because 8 is great. So if we're looking at aluminum, I just wanted to show you a different way. What he means by fill in or fall back. Okay. So basically, if we're looking at aluminum, he has 2 different noble gases he could look like. The 2 closest here, he could either look like argon, okay, here, or he could go backwards and look like neon. These are the 2 that he's in between. So if he wanted to look like argon, he would have to gain 1, 2, because you said he has 3 valence electrons, right? So if he gained 1, that would be 4 valence electrons, 5, 6, 7, 8. He would have to gain 1, 2, 3, 4, 5 electrons for him to look like argon. Okay. Or he could go backwards and lose some electrons. He could lose 1, 2, 3 electrons and look like neon. You're always going to do whatever is easiest to do. It's a whole lot, which in other words means whatever's the less number. Okay. So it's a lot easier for him to lose 3 electrons than it is for him to gain 5. Okay. So that's why he does that. And what we learned on the video, I hope you wrote down, is that realistically, anybody that's going this way, who is a metal, anybody left of the staircase, which are your metals, they always lose electrons. That's what they do. It's easier for them to do that. So if you didn't have this written down, you should know that metals always, they lose electrons, okay? And if they lose electrons, okay, this is kind of the thing that's kind of weird. If they lose electrons, that means they have a positive charge because now they have more protons than they do electrons, okay? And if they have a positive charge, what's the name for a positive ion?
Okay, I can't say it. It starts
What
with
word
a
does it look like? What's the first word look like? Cat. It's a cation, okay? Cation. And how you remember that the cation is the positive one is because this T looks like a plus sign, okay? So that means everything else is the opposite. So if we were talking about nonmetals, what's the opposite of all this stuff that we just wrote? Nonmetals do what?
gain.
Gain electrons, okay? What type of charge?
Negative.
Negative charge. Negative charge. And then does anybody remember the name of a negative ion?
Anion.
A negative ion. It's an ion. An ion. Okay, an ion. All right. So that's one of the things that I want you to make sure that you remember. Okay. So this is going to be essential. All right. So anybody that's a metal, which is left of the staircase, they're going to lose electrons. Anybody to the right, they're going to gain electrons. Okay. Now, let's talk about why they do that. Well, we kind of already did. It's easier for those who are already past having 4 valence electrons to just get a couple more. Okay. That's the easiest thing for them to do. Okay. All right, so now I'm going to erase just a little bit of stuff, okay? I want to erase everything just in case you're writing some stuff down, okay? All right, so now what we're going to talk about today is a trend, okay? So when we talk about trends, we have to discuss them in 2 different ways, okay? One is, what is the trend within a period? And the other one was, what's the trend within a group? If you're online, can you see that towards the bottom of my screen? You guys can see that, okay?
Yes.
Yeah.
All right. So let's think about this for a second. First thing I want to do, make sure we know all of the terms for a period, okay? So a period, which way does that go? Very nice. Eric was going like this with his fingers. So they go left and right, okay? And then could somebody tell me, so that means a group goes this way, okay? Groups go this way. All right. Who else is it a period or group that also has the name family?
Group.
Groups, very nice. Groups are also known as families. All right. And then Marco, are you there?
Yeah.
Okay. Marco, how about a row? Do you think a row goes left to right, or does it go up and down, a row? So one is going to be row and one is going to be column.
Bro, isn't it go left to right?
Exactly. So this one is a row. Say again, Joe. Groups are known as families. Yes, groups are known as families. And that means these are also known as columns. All right. So now I just want to make sure we had all the names for these. So period, left to right, also known as a row. What does the row tell us? The amount of rings. Very nice. And this tells us the number of rings. Look at all this stuff that we can write down. And then the group or family, we already talked about this. This tells us the number of valence electrons. All right, so that's just kind of a quick review. So now, when I ask you about a trend, okay, when I ask you about a trend, what I want to know is, does it increase or decrease moving in a particular direction, okay? So anytime I'm asking you about a trend, we have 3 trends we're going to learn. I'm going to say, I may say something like, which one is the highest, or which one is the lowest, or put these in increasing order, or put these in decreasing order, okay? So we always have to know, is it increasing, going left to right, or is it going left or going right? And is it increasing, going up or going down, okay? All right, so I'm going to erase some of this now. All right, and we're going to talk about this new trend we got, okay? The name of the trend is called electronegativity. Electronegativity. All right, and I'm going to make this just a little bit smaller so that we have room to write. Okay, let's see if I can just hit. Nope. All right. All right, so the name of the first trend I want to talk about is electronegativity. And I'm going to get you to try to guess the trend first, okay? Because I think you can based off of what we just learned. So the name of this one is, again, electronegativity. E-L-E-C-T-R-O, negativity. Okay, electronegativity. All right, I'm gonna tell you what it means, and then I'll give you like the actual definition. Okay, but what it basically means is when we're talking about electronegativity, is who wants electrons the most? Okay, so when we're talking about this, we want to talk about who wants electrons the most. Who, I'll make a note of that. Who wants electrons the most? Who wants electrons? I'm going to shorthand electron the most. Okay. All right. Now the fancy sciencey way of saying the definition is the tendency of an atom to attract electrons. Okay, the tendency of an atom to attract electrons. Those mean the same thing. I like to just say, all right, who wants electrons the most? But the technical definition is the tendency of an atom to attract electrons. Okay. All right, I'll give you a second to get that down. All right, so I just drew my box back around the noble gases because we know everybody wants to be like the noble gases, okay? They are the it crew, okay? They have 8 valence electrons and everybody wants to get 8 because 8 is great, okay? So my first question to you, I want you to think about is, if we were looking at a period, okay, which goes left to right, the question is, does it increase or decrease? Let's just specifically say, I could say going left or going right, but let's just say increase or decrease going towards the right, okay? So I want you to think about it for a second. Think about what you know. Think about the definition of electronegativity. Who wants electrons the most? As we go to the right across a period, do you think an atom's desire to get electrons would increase or would it decrease? So think about it for a second. Don't answer just yet. Okay, so as we go this way on the periodic table, okay, as we go this way and we think about who wants electrons the most, would that increase as we go across the table or would it decrease as we go across the table? Okay. Would anyone like to, and it's okay, we're learning, right? So if you guess and you guess wrong, that's fine. That just means now you know the answer. Would anybody like to guess and explain why they think what they think?
I think increase.
Okay, and why do you think increase, Whitney?
Because the more you move to the right, the more valence electrons that you have. So instead of subtracting them, you will want more, like you can easily attract, because the magic number is 4. So you will have like either 4 or more. So
Excellent.
yeah.
Yeah, you're right. All right, so Whitney, and there's a couple of different ways you could say it, okay? But she's right. As you go to the right, you're going to increase in electronegativity, all right? If you think about it this way, look, this group right here, this first group, the alkali metals, they don't even want their electrons. They're trying to get rid of them. No way do they even want to attract more. This group, they don't want electrons. Group 3, they don't want electrons. All these groups are trying to get rid of them. But as I start moving towards the right, as I keep moving towards the right, okay, they want them pretty bad. Now, let me ask you this. What family, and I'll even give you some options. You have alkali metals, alkaline earth metals, transition metals, and the halogens. Who do you think wants electrons the most? Like they want them so bad.
Halogens.
Okay. Anybody agree, disagree?
What's the one closest to I think it's halogens, like what I think that.
Yep. Okay. Eric said he agrees with you. Halogens. Halogens is the family right here. Oh, except for I just erased it. Okay. Let me draw. This family right here is the halogens. Okay. You are absolutely right. They want them more than anything else. Now, someone said, and I get this all the time, someone said noble gases, and I'm glad they said this because I want to address this. Noble gases have 8 valence electrons, right? Do they want to gain any more than 8 electrons?
No.
Do they
No.
want to lose any? So really, actually, noble gases don't even have electronegativity. But it's easy for you to be like, oh yeah, they're the closest. They are noble gases. They really want electrons. No, they actually don't, because they're like, I'm happy. I don't want any more. I don't want any less. Okay. So the halogens, okay, as you go to the right and you get closer to the halogen family, you will increase in electronegativity. All right. Now here's the hard one. Now we got to think about it within a group. Okay. So let me give you a visual for this one. Let's see if you can figure it out. Okay. All right, here we go. So let's pretend that you have, let's look at these. Let's look at fluorine, chlorine, and bromine. Okay. Let's just take a wild guess first. Who do you think Joe, who do you think will want it more? Fluorine, chlorine, or bromine? Who do you think wants electrons the most?
Chlorine.
All right, Joe says chlorine. Dominic, who do you think wants it the most?
You're talking about electrons?
Yeah, who out of these 3 do you think would want electrons the most? And we're just guessing right now because I haven't explained it.
I guess BR.
BR, okay. Fisher, who do you think?
Chlorine.
Chlorine, and then Darren, what do you think?
I had just now got back from the bathroom. What was the question?
Of these 3, who do you think wants electrons the most? FCl or BR?
Who do you think wants electrons the most?
Yes. It's just a guess. You don't even have to give me a reasoning.
Probably BR since it's lower, right?
Okay, BR. All right, so most of us said BR or CL. Now, let me show you guys. Let's do a little visual aid, all right? Let's pretend here's fluorine. Let's pretend that's his nucleus. How many, let's see, he would have 2 rings because he's on the second row. 1, 2 rings. All right, now let's do Cl. Okay, here's his nucleus. And he would have, he's down 1 row, so he has 3 rings. 1, 2, 3. All right, and then we have Br. There's his nucleus. And he has 4 rings because he's on the 4th row. 1, 2, 3, 4. All right, so here are our 3 atoms. How many electrons does the first ring hold? 2.
2.
1, 2. That shell is full. 1, 2. Ring is full. 1, 2. Ring is full. How about the second one?
Isn't it 8?
It holds 8. However, all right, fluorine, let's look at him. He should have 9 electrons. Oh, and we're in the 7th row. So how many valence electrons should he have?
7.
Very nice. So if we do 7 on this outside ring plus this 2, that's his 9, right? So he has 1, 2, 3, 4, 5, 6, 7. All he needs and all he wants is 1 more electron right there. All right. It's really going to be the same for the rest of these. Chlorine, this ring is completely full. 2, 3, 4, 5, 6, 7, 8. His valence shell is going to have how many again? 7 because they're all in the same family. So their last one is always going to have 7. 2, 3, 4, 5, 6, 7. All he wants is this one right here. And if you wanted to double check, chlorine is supposed to have 17 electrons. Somebody can double check if you want and make sure he has 17 right now. That red one doesn't count. While you're doing that, I'm going to go back and fill in bromine. This one would have 8 because we know this shell is full. We have to fill it up before we can go to the next one. And then this one would also be full. And this last ring would have how many? How many, Joe?
7.
7 again. All right, and he again just wants this one last electron. Now, remember the whole goal is for you to meet the octet or for your shell to be completely full. Now let's look at the 3 of these, okay? Who do you think out of these 3 with all their lovely electrons is like, oh my gosh, please, 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 I just need one more electron. I'm just trying to get a full shell out of the 3.
Fluorine.
Who'd you say?
Fluorine.
Fluorine, poor little fluorine. He's only got this one shell that's full with his 2 little rings. Okay, his 2 little electrons. He's like, oh my gosh, if I can just get one more electron, one more, I can have a full shell. Chlorine over here, I mean, he's saying the same thing, but at least he has 2 shells that are already full. And then bromine's got 1, 2, 3 shells that are full, and then he wants that one, okay? So with that being said, fluorine wants it more than anybody else on the entire periodic table. No one wants electrons more than fluorine. So here's what you can do to remember that, okay? If you can remember that poor little fluorine right here, thanks. Poor little fluorine right here wants electrons more than anybody else, you can actually remember the trend, okay? He is the most, I would actually write that down, the most electronegative is fluorine, okay? So as long as you are moving towards him or whatever element is closest to him, that's who's going to be the most electronegative, okay? So that means if we're looking at groups or family and I ask you, does it increase or decrease? Let's be careful. Let's say if we were going down, is electronegativity increasing or decreasing going down?
Decreasing going down.
It is decreasing going down. So here's what you need to do. You can either say, okay, remember that it's decreasing going down, or you can say that it's increasing going up, okay? But as long as you're moving towards fluorine, you should be okay, okay? So let's do just one practice problem, and then we'll be done for the day, okay? All right, so here's the type of problem that I could, hint, hint, ask you on a test or quiz, okay? I would say something like, I would give you a few elements, okay? I would give you something like calcium and iron and copper. Okay, this is how I could word the question. I could say, who is the most electronegative? Or I could say, who is the least electronegative? Okay. Or I could say, please list these in order of increasing electronegativity, or please list these in order of decreasing electronegativity. Okay. So that's the 4 different ways I could ask you about this. Okay. And I could give you like 4 or 5 elements. I probably won't give you more than 4. Okay. But if I asked you, let's see. If I asked you to list these in order of decreasing electronegativity, take a second, decreasing electronegativity, decreasing Now, if I say decreasing, who should come first, the biggest or the smallest? If I say list in order of decreasing.
Biggest.
Right, if I say decreasing order, so decreasing electronegativity, then you should go from big to small, or most to least, however you want to say that, okay?
So CUFECA.
Okay, very nice. All right, so Eric answered, he said it should be listed as CU, then FE, then CA. And he's correct, okay? So this one will be first. He's the most electronegative. This one would be second, and this one would be last, okay? So this will be first, second, last. All right, one more, I promise, and then we're done. All right, how about, let's do, I'm gonna erase some of this. All right, how about, let's go in increasing electronegativity, increasing electronegativity. So think about what that means. Okay, increasing electronegativity. And let's do lead, which is PB. SI, which is silicon. And let's do GE, germanium. Okay, so this is increasing. And I'm sorry, I didn't tell you. I usually write EN for electronegativity just because I'm lazy, okay? EN. Increasing electronegativity, so don't say it out loud yet. Matter of fact, let's put these, let's throw them in the chat. And then once I see your answers, we can get ready to log off, okay? So list these in order of increasing electronegativity. Increasing electronegativity, okay? Increasing, so that means small to big. Small to big. You can throw them in the private chat to me. Very nice, Amos, yes. Where am I looking?
Right there.
That's a J.
No, G.
Dominic, very nice. Increasing
Wait, Miss,
electronegativity.
Is that right?
Say again?
Is that right?
I don't see yours, Whitney. Let me see, unless they're over here.
That's Jamie.
I made Jamie. That's what I say.
Oh my.
No, I knew. Sorry. Oh, other way around. Other way around. So usually the hardest part is remembering which way is increasing. So increasing is from the smallest or the least to the biggest, small to big. Okay. So real quick, and then we'll close out. All right. Who is closest to fluorine?
SI.
SI. So he should be last. Okay, because we're going from small to big. So who should be first? PB, and then it should be GE. All right, PB, GE, SI. All right, we're going to do more practice on Wednesday. Good job today. I will see you guys on Wednesday.